Imagine this, a rogue wanderer from the depths of another star system, hurtling through our cosmic neighborhood at over 130,000 miles per hour. It's not a spaceship from a sci-fi blockbuster. It's Comet 3I/ATLAS, the third interstellar object ever spotted in our solar system. And right now, as of early October 2025, it's zipping past Mars on its way to a fiery close encounter with the Sun. Discovered just 3 months ago, this icy visitor has ignited a global frenzy among astronomers, sparking over 70 research papers in record time and challenging everything we thought we knew about comets from beyond our home turf. Why does it matter? Because 3I/ATLAS isn't just a rock from space. It's a time capsule, potentially billions of years old, carrying secrets about alien worlds that could rewrite our understanding of how planets form across the galaxy. In this video, we'll dive deep into its wild journey so far, from its explosive discovery to stunning telescope snapshots, bizarre brightness flares, and even whispers of alien tech. Stick around as we unpack the science, debunk the hype, and gaze toward its dramatic perihelion on October 30th. If you're a space newbie or a seasoned stargazer, buckle up. This interstellar comet is about to blow your mind. Let's rewind to that electric moment in early July 2025. Picture a quiet night in Rio Hurtado, Chile, where the Atlas telescope, NASA's Asteroid Terrestrial Impact Last Alert System, is scanning the skies for potential Earth threateners. Suddenly, it locks onto something weird, a faint streak moving way too fast for anything born in our solar system. Boom! Comet 3I/ATLAS is born, named for its interstellar status, the third after the cigar-shaped enigma Oumuamua in 2017 and the gassy Borisov in 2019. Unlike those, this one's a speed demon, clocking 58 kilometers per second, an ancient, maybe 3 to 11 billion years old, predating our own solar system's 4.6 billion year clock. Back in my last video on this comet, we had just 4 papers to chew on. Fast forward to now, and it's a research avalanche. Nearly 70 studies, each peeling back layers of this cosmic onion. But before we blast into the fresh finds, a quick reality check. Amid the headlines screaming alien probe, what's the real scoop? This comet's no threat. It'll swing by Earth at a safe 1.8 astronomical units, or 170 million miles. Yet its path, a hyperbolic slingshot unbound by the sun's gravity, screams outsider. Fun fact, if you could hitch a ride, you'd cross from Pluto to the sun in under a year. That's the hook of interstellar comets. They're rare postcards from distant stellar nurseries, and 3I/ATLAS is delivering in spades. Our first big break came from the stars themselves, courtesy of NASA's Hubble Space Telescope. Securing time on Hubble is like winning the lottery. Proposals stack up months ahead. But for targets of opportunity like this speedster, it jumps the line. On July 21st, 2025, when 3I/ATLAS was 446 million kilometers out, Hubble snapped a gem, a streaky starred image showing the comet's teardrop dust cocoon. Those streaks, proof of its blistering pace. Scientists crunched the pixels and nailed the nucleus size between 440 meters and 5.6 kilometers across. That's tiny compared to early guesses of 10 kilometers, which lumped in the coma, that hazy gas dust halo. Now, with dust settled, we're seeing the core. A dirty snowball, icy and rocky, sublimating under solar heat. Imagine it like a cosmic ice cream cone melting in the sun's breath, drips of vapor forming that coma. These shots weren't just pretty, they refined our models, showing how reflectance plays tricks on distant eyes. And Hubble's not alone in the spotlight. Enter the James Webb Space Telescope, JWST, the infrared wizard orbiting a million miles from Earth. On August 6th, led by astrochemist Martin Cordner, JWST's near-infrared spectrograph pierced the veil. The verdict? A wild coma with patchy outgassing, carbon monoxide and dioxide dominating over water. For now. That's shifting as it nears the sun, like seasons in a bottle. But the shocker, dust blasting toward the sun, not away. Why? Fragmenting grains reflecting extra light, maybe turbocharged by CO2 launches. It's like the comet's exhaling fireworks, hazy glow hiding drama. These peaks from Hubble and JWST, they're gold for space exploration, letting us taste chemistry from another star system without leaving home. But wait, NASA's telescope squad runs deeper. The Transiting Exoplanet Survey Satellite, TESS, has been globe-trotting the sky for 7 years, hunting alien worlds around bright stars with its 4 wide-field cameras. Turns out it's a comet whisperer too. Pre-discovery data? TESS caught 3I/ATLAS as far back as May 7th to June 2nd, 2025, predating the official spot by weeks. Astronomers Adina Feinstein, John Noonan, and Daryl Seligman dove into those deep stack composites in a September 11th paper. Expected? A modest brightening as it closed 0.9 astronomical units on TESS, bumping flux by 1.5 times to magnitude 20.5. Reality? It flared to 19.28, a five-fold flux jump. Ground telescopes like TRAPPIST North and South backed it up. This surge screams hyperactivity. Combining with Hubble's size, it hints 3I/A TLAS was outgassing at 6 AU, the fringes where most comets snooze. Exotic volatiles like nitrogen or hydrogen? Likely culprits fueling this early wake-up. Picture a sleeper agent activating light years from base. That's our comet defying norms. And the light curve? Flatter than Oumuamua's, suggesting even reflectance. No wild tumbling. Test data teased periods of 29 or 16 hours, but noise muddied it. Ground scopes confirmed 16 hours, painting a squat spinner, maybe elongated like a rugby ball. These insights from TESS bridge exoplanet hunts to comet chases, showing how one mission multitasks in the vast space exploration tapestry. As 3I/ATLAS heats up, its secrets spill out, literally. Ground-based GEMS from Gemini South in Chile on August 27th unveiled not just the coma, but a tail stretching 1/120,000th of a degree, longer than July's stub. Proof positive, activities ramping as perihelion looms. Spectrograph magic caught cyanide emissions in the CN band. Hydrogen cyanide photodissociating from water ice at 2.5 to 3 AU. A September paper clocked 8x10 to the 23rd molecules per second. Low for solar system comets, but telling. The C2 to CN ratio, under 0.09, marking it carbon chain depleted, low on Debris and tricarbon. Borisov shared this trait. Oumuamua? Silent on gases, formed in cold carbon-poor nurseries? Maybe. But hold on, amateurs Michael Yeager and Gerald Remen snapped it green over Namibia during the September 7th to 8th blood moon. Green? C2 fluorescence at 518 nanometers. Odd for a depleted comet. Ramp up or illusion? Jury's out, but it's gorgeous, pulling backyard astronomers into the fray. Then polarization. Zuri Gray's September 5th paper from scopes in Chile, Canaries, and Bulgaria revealed a deep, narrow negative branch. Light scattering parallel to the Sun-Comet observer plane, unseen in solar comets or asteroids. Even Borisov went positive. This echoes some trans-Neptunians, hinting unique dust, fine grains or weird regolith. Polarimetry is like a fingerprint for dust size and coma shape. Here it's exotic, classifying 3I/ATLAS in a mystery league. These traits, tail growth, cyanide whiff, green glow, polarization quirks, paint a fragile beast as comet guru Karen Meach calls them. Really very fragile, dirty snowballs. Breakup risk? High. Expose fresh ice and emissions explode. Of course, no interstellar drama skips the aliens chorus. Enter Avi Loeb, Harvard's bold astrophysicist, who's made headlines chasing ET artifacts. In July papers, he flagged early 10-kilometer size estimates as too massive for interstellar odds, floating tech probes. His follow-up, is the interstellar object 3I/ATLAS alien technology? With interstellar nonprofits, dove into astrodynamics, Non-grav boosts for Venus-Mars-Jupiter flybys? He nods to Dark Forest Fermi. Paradox, aliens hiding like cosmic deer. Fun? Sure. But critics like Malaysia's AKM Yasinul Haqian rebuttals slam outdated data. Hubble's August 7th release capped it at 5.6 kilometers. Loeb stuck to old numbers. Trajectory? Natural gravity fits better than maneuvers. Lesson? Science thrives on wild ideas but anchored to facts. Jumping to ET skips the grunt work. Peer review, fresh data. Loeb's push sparks debate, sure, but for Interstellar Comet explained, it's natural wonders first. Remember Oumuamua's sail hype faded to outgassing. Borisov's CO to icy ejecta. 3I/ATLAS, question mark, same script, richer plot. Fast forward to this week. October 2025's plot twist, Mars gets a front row seat. As Earth-based views fade behind solar glare, ESA's ExoMars Trace Gas Orbiter and Mars Express pivot like pros. From October 1st to 7th, with closest pass October 3rd at 30 million kilometers, they snag the sharpest snaps yet. ExoMars Cassis camera, GF, shows a fuzzy white dot, nucleus plus coma, thousands of kilometers wide, sliding downframe. No tail visible yet. Distance blurs the kilometer nucleus like spotting a phone on the moon. Mars Express's max exposure shots, stacking for clarity soon. Spectrometers hunted spectra, but faintness, 10,000 to 100,000 times dimmer than Mars turf, challenged them. NASA's Swift added juice. July 31st to August 19th. UV hunts nabbed OH gas, water's smoking gun, at 3 AU, 40 kilograms per second loss. Unlike dry Oumuamua or CO-loaded Borisov, this one's water wakes early, vaporizing tiny grains in sunlight. Layered ices? Complex history from another system. Implications? Compares to home comets. Probing diverse planet-build recipes. Quotes from the front. ExoMars P. Nick Thomas. This was a very challenging observation. 10,000 to 100,000 times fainter. ESA's Colin Wilson. Extra exciting, responding to unexpected situations. And Comet Interceptor's Michael Keppers. Visiting one could provide a breakthrough. NASA's fleet, Hubble, Webb, TESS, Swift, SphereX, even rovers like Perseverance, piles on with SOHO and JUICE eyeing post-perihelion. We've raced with 3I/ATLAS from Chilean hills to Martian orbits, unearthing a comet that's faster, older, brighter, and weirder than kin. Key takeaways? It's a water-active, carbon-lean speedster with unprecedented polarization, outgassing exotics at solar system's edge. Clues to alien formation zones. Controversies remind us, speculate boldly, verify rigorously. As it hurtles to October 30th, perihelion at 1.4 astronomical units inside Mars' loop, will it flare supernova bright, sprout a tail miles long, or shatter like glass? Re-emerging December for JWST and Gemini Encore. What fresh volatiles spill? Trace its Sagittarius origin, another system's wreck? These questions fuel space exploration's fire, turning what if to what is. Ponder. If comets like this seed life across stars, are we all interstellar travelers? Hit like if this comet quest sparked your wonder. Subscribe for perihelion updates and interstellar deep dives. Comment your wildest theory below, aliens or ice. Check my July vid for the origin story and related playlists on rogue objects. Thanks for exploring with me. Clear skies and keep looking up.